6, Radical Equations and Problem Solving. So what's the next step? Solving radical equations. So here's an example of a radical equation, okay? We're trying to figure out what values of x make the equation true. Many of you probably could make a guess about what value of x would make this equation true, but of course we would like to learn a technique. So, thinking about how square roots work, right? What's a good way to get rid of a square root? Square it, right? The square root and the square cancel each other out. So the basic technique that we're going to be looking at is squaring both sides of the equation to get rid of the radical. So here are the full steps. You need to isolate. It says isolate one radical, and most of the time there's only one radical. We'll do a couple with two. So you always want to isolate the radical and raise each side of the equation to a power equal to the index of the radical and simplify. So when they say equal to the index, we'll see a few where we're going to be doing cube roots, so we'll have to raise both sides to the third power. Right? And then it says if the equation still contains a radical term, we might have to repeat steps 1 and 2. Now here's another really, really important step, which says check all proposed solutions in the original equation. So when we think about techniques for solving any kind of equation, you always want to do the same thing to both sides of the equation, and it's totally okay if you add the same thing, subtract the same thing, multiply, divide. Later we'll learn about square rooting and things like that. And it's a totally legal move to square both sides of the equation, but every once in a while you end up with an extraneous solution. And we saw this before. We've seen extraneous solutions where we ended up with a 0 in the denominator. And the same thing will happen with radical equations. Sometimes we'll have negatives underneath the radical. Sometimes there'll just be weird situations where we're doing all of the steps right, but we still ended up with an answer that doesn't work. So, unfortunately, you always have to check your work with radical equations. Even if it's just checking enough to make sure that there's not a negative under the radical, or just checking really quickly that it is not an extraneous solution. So let's just go ahead and try one of these examples. Okay, so this is just kind of going back to that first example I said. So what we're going to do is we are going to square both sides of the equation. So I'm going to kind of show my work here if I can find my pen. Okay, so what we're going to do is we're going to have the square root of x plus 2, and we're going to square that side of the equation. And of course, we need to be fair to our equation, so we need to square the 5 as well. So, what do you guys think the square root of x plus 2 squared is? X plus 2, right? The square and the square root cancel. We have x plus 2 equals 25. This one, luckily, was just a very simple linear equation. Of course, we're going to end up with some that are quadratic, and we'll have to use factoring or something like that. So, our assumption at this point for our solution is 23. We still need to make sure that it's not an extraneous solution, but on this one, it doesn't take long to plug that 23 in and see that 23 plus 2, right, square root of 25 is obviously equal to 5, and so we're good, right?